So we're going to talk now a little bit more about the global temperature at recent times. So before doing that, we're going to define the different scales that we have discussed and how these ones are they have given an explanation of the changes in temperature. So something that is clear is that the change in temperature that has occurred over the past 100,000 years is within the range of 5 to 6 degrees. And the recent variation in temperature that we're talking about on recent times is more shorter. So in this slide, we can see that the climate has always been changing. And we have explained, we have divided this in different time scales, and we have discussed the orbital variations, and now we're going to discuss more recent times. And this discussion includes like the 100 to 10 year time scales and the 10 to 5 year time scales that involves El Niño and La Niña. So when we're talking about the 100 to 10 years scale, 100 to 10 year scale, we also talk about some special periods that are called the medieval warm period and the little ice age period. So little medieval warm period was an unusual warm period in the northern hemisphere, and that's why it's not that clear when we see global average temperatures. We don't see this variation, significant variation. But this has been thought that it may have been caused by the low sunspot activity and also the low volcanic activity that, as we have mentioned before, has significant impacts on climate as well. This is a figure of the more recent global temperature. And one of the important key difference from what we have discussed before is the range in temperature that we're talking about here. So the difference in temperature is no more than 1.5, even less than 1.5 degrees here. And when we were talking about ice age periods, we were talking about a difference of 5 to 6 degrees, right? These measurements are measurements that have been done now with more advanced devices, even with satellite image from the beginning of the 1980s. So what we see here is some oscillations, and these some of the outstanding peaks are connected to, for instance, volcanic eruptions. And then also we have some interesting periods. For instance, the one that is within the range of 1940 to 1980, which is attributed to the is a decrease decrease in temperature that was associated with the presence of sulfates caused by the growing use of fossil fuel. The presence of these compounds which are grouped as aerosols, not only sulfates, have the ability to reflect sunlight back into space. So this can mask actually what is going on the increase of building up of other greenhouse gases that can cause global warming. So then when there were better regulations about the using of fossil fuel containing sulfates, etc., then we stopped to having this mask period, right? There are some other also outstanding record of temperatures. For instance, 15 of the hottest years on record all occur in 1990. But now these are actually a figure that goes up to 2010. There are now more recent figures where we actually know now that we have more outstanding record temperatures, right? In different regions of the world. This is not only focused on one. So now we can analyze more recent times, and we can analyze also how temperature varies along the planet. And what is interesting to see is that the anomalies in temperature or maximum values achieved temperature in the planet has been more often in the northern hemisphere, and this is associated with the amount of land that is as compared to the one that is in the south. So this is related to the heat capacity, right? Heat capacity of the water and heat capacity of the land, right? So the water is an important component, as we have discussed before when we relate this to the ice cover. It also has the capacity to storage energy, and this energy allows to maintain, to not to have significant variations in temperature, right? Because that is connected to energy, is connected to the variations in temperature. But in the northern hemisphere, so we have more land and other things going on associated to the variations in temperature that we will explain later. But this is key, like the heat capacity of the water as compared to the heat capacity in regions where there are more predominantly land. All right. So here I am showing you a very nice short video where we can see the variations of the temperature in different decades, so in a high-speed mode, and clearly you can see that there has been an increase on outstanding or anomalies in temperature. So now we have to ask ourselves, what is the main cause of these temperature variations? And we have talked about eccentricity, obliquity, and precession, and the impact on this temperature, right? And we have seen that the main impact is due to the incidence of solar radiation, but also that is due to eccentricity, and then the distribution of the solar radiation that is caused by obliquity and precession. But it's not the whole story. So we have other impacts, other things that can cause or amplify the variations in temperature. And one of these aspects is the presence of the gases, not only the greenhouse gases, but the scientists also have looked at other gases, such as the sulfate gases that we also discussed before in this lecture, right? So let's look now at the CO2 concentrations, and then let's see the temperature variations and how these are correlated. What we can see here is that the CO2 is highly connected to the temperature, to the variations in the temperature. And these measurements have been done from for thousands of years by taking the samples that I was mentioning to you, the ice core, the bubbles in the ice cores, where we could also see CO2 trapped. And this CO2 trapped change because of the holding of the CO2 from the oceans due to the variations in temperature, for instance. So the higher temperatures in oceans, that are the majority of the world is covered, the planet is covered by water, and this water can hold significant amounts of CO2. But if if there is some temperature variations, the CO2 can be released, or can be more stored, right? So we have these records, and now we have more recent records about the CO2 concentrations in the atmosphere, and we can clearly see that there is a match, right? There is a correlation between temperature variations and CO2. But let's look at the final part of this figure, because this is highly important and highly something to be worried. Because if you know now, can you remember what is the atmospheric CO2 concentrations of at this time? Well, it is about 400 ppm. So imagine what are we facing, what we are about to face in terms of temperature. So that's why there is a big concern, and we're going to discuss now how this greenhouse gas effect has a role on the temperature, and what is the key role of the CO2. So CO2 emissions are being measured all over the world, and one of the stations, the key observatory stations, is the Mauna Loa in Hawaii, where they have the longest record of direct measurements of CO2 in the atmosphere. It dates back to 1958, and they have measured this that corresponds to the northern hemisphere. I just want to mention about this example that there is some clear oscillations that are annual oscillations, and these oscillations are connected to the photosynthesis processes that are going on during warm periods, and the release or the difference in CO2 of the cold periods. So these oscillations are referred to that.